Hi, so in video 1476 we made this out of tablespoons. It's a turbo turbine. It's named after the guy who invented it, and I did a load of welding. But I also copied it in this one, which is a load of plastic spoons glued to a disc on Welcome to the World of TNT, because that's a much easier version to make. And I was asked, well, will that work in the wind? Will it work under compressed air? And of course the answer is yes, but there's no easier way to demonstrate that than to put a bit of wind on it. So I've got a hairdryer. That's kind of awesome, isn't it? And if you look at it, aren't you reminded of the wind pumps that dotted the American landscape until about the 1960s? It looks very similar. It's a whole load of blades arranged, and of course it begs the question, if a whole load of blades like that work, why is it that these American wind pumps have died out and just about every single wind turbine you see has got a three-bladed design? Well, of course, there's a good reason for that. When we look at these blade designs, we're actually looking at a combination between the aerodynamic efficiency and the drag involved in a blade design like that. Surprisingly enough, the most efficient kind of turbine has one blade on it. If you put one blade on there, of course, it costs 2/3 the price and it generates a huge amount. You had two blades, you get about a 10% increase, and three blades, you get another 5% increase. But in terms of cost and efficiency, a single blade's brilliant. Of course, the problem with a single blade is if you try to turn something like that, it just wobbles itself to pieces. The same thing with two blades, you get a thing called precession, and it will wobble itself to pieces. Three blades is where you get the kind of stability required for something like that, and you get the best output performance because the blades don't interfere with each other, causing turbulence and drag within the swept area of the rotor. And so we have a three-bladed design, and that three-bladed design has become more or less universal. Now, the number of blades in the swept area is called the blade solidity. So the blade solidity with three blades represents the most efficient way of getting wind energy out and transferring it into electrical energy. And that's brilliant. However, there is an issue with that. And the issue is, if you design your blade, stick it in a wind tunnel, do all the testing, work out all the efficiency, stick it on a big pole 100 meters up, it'll perform more or less the same as it did in the wind tunnel. But if you then take that same design and stick it in a built-up area, or a few meters tall instead of 100 meters tall, turns out it's a different story. And it kind of illustrates, I think, the limitations of how we view things. When wind tunnels are made, and when the models are made, and when the thing is built, the ideas that we were using were actually pretty limited. Now, they're pretty limited because the kind of modelling that went on for airflow at 100 meters high was, pretty good, but it was modelling airflow 100 meters high. When you bring that down, so it's maybe 10 meters high, the airflow is very, very different. So you can't apply the model of the airflow 100 meters high to the airflow at 10 meters high, and yet that's exactly what's done. Now, don't get me wrong, the best wind turbines that have been designed are approaching 80% of the BETS limit, which is incredible. So that process is clearly working. It's clearly a great process for working out how to design a wind turbine if you happen to want a megawatt installation wind farm. Works perfectly. It also gets us into the situation where we say, well, what's the best wind turbine? And the answer is the best wind turbine for a megawatt generation where you're hanging your blades 100 meters high is a three-bladed aerodynamic blade, HAWT system. Spot on! But then we take that and translate it into a completely different environment. Turns out that same 80% efficient turbine 100 meters up drops down to something like 30 to 40% efficient if you stick it 10 meters up or in a built-up environment. Is it any wonder we're all upset at the performance of home-based wind turbines that say proudly on the box 100 kilowatts, but after a day's work will barely boil enough water to make a very small cup of tea? And if you don't read, you might think that this is a problem that nobody's thought about, but it turns out It's a problem everybody's thought about. Loads of people are thinking about this thing. And when it comes to the different environment, it looks like having multi-blades on a turbine is actually better than 3 blades on a turbine. And there's been a lot of research into multi-blade turbine designs at 10 meters to rural environments and built-up environments in that low turbulent air. So I've put the steel version into the bearings. Now this has a lot of problems as a wind turbine. It's heavy. It has a lot of resistance. It needs a lot of wind to get it going. And if I get it going, it does that. It continues to spin even though the wind is removed, and that's because it has a lot of inertia. The inertia that it has means that it takes a higher wind speed to get it started, but it has more torque on the shaft, and it will continue to spin when the wind dies because of its own inherent inertia. Now, the mass of this, the solidity, the number of blades, its inertia, the starting torque, they're all big problems if you want to hang this 100 meters high. But they're not big problems if you want to hang this 10 meters high, which is why these things dotted the American landscape for such a very long time. I mean, windmills have been around for millennia. You can bet your bottom dollar that the people in the past were as inquisitive as us, and they've had a good look at the number of blades, and it turns out that 10 to 28 blades is pretty good. Now that's not a guess, that's based on the current research, having a look at some papers on Google Scholar to find out what, if anything, multi-bladed wind turbines had to offer. They don't offer jack at high environments in the same way as a megawatt installation would, but they offer considerable amount at lower elevation. Of course, efficiency is the saint that we all seem to be worshipping at the moment. And it is extremely true that the wonderful 3-bladed wind turbines on megawatt farms 100 meters high are approaching 80% of the Betz limit. Absolutely. But the problem with turbines is turbines don't actually depend on blade design as much as we think they do. They also depend on the environment in which they're operating, which seems to be ignored very frequently by lots of people. If you take that very same turbine and drop it down to 10 meters high or put it in a built-up environment, the efficiency drops off ridiculously. Turns out it's about 30-40% efficient, something like that. These things, which scattered the US, are about 30 to 40% efficient. At one time, about the 1960s or so, they were responsible for something like 150 megawatts of generation, which is not inconsiderable. So I'm reasonably convinced I'm going to get the Animal Farm response, you know, the one, 2 legs bad, 4 legs good. But if you have an aerodynamically designed 3-bladed horizontal axis wind turbine, it's the best kind of wind turbine if it's 100 meters up and part of a megawatt installation. You drop it down to about 10 meters or stick it in a built-up urban environment, then it's not so good. And the efficiency drops off so markedly that something like this, which has about a 30-40% efficiency, a multi-bladed turbine, works pretty much just as well. And it means that other considerations have to come into play. And those other considerations tend to be things like ease of manufacture, like amount of maintenance, and the environment in which you can put it. That sort of thing becomes much more important than that all-important efficiency that we're so proud to bow down before. These multi-bladed turbines, I've seen them in the research made from flat panels with a 30-degree twist in them, and they've worked just fine. This one, it's a bit too dense. We'd need to remove this so that the solidity was less, because we've got 36 spoons in there, so maybe half of that would give us a better result than putting 36 in. But certainly multi-bladed turbines are an option to be looking at when it comes to lower down DIY installations than trying to replicate what's more appropriate for a different environment. Now, I'm not saying that 3-bladed turbines aren't good. They are good. I'm saying that what needs to be thought about is the environment in which they're operating. The environment in which a DIY turbine or a lower level turbine operates is very different to the environment in which a HAWT 3-bladed megawatt installation turbine operates in. Anyway, I thought they were interesting, and I thought it was interesting because of the question I was asked, and of course the very next thing I'm going to do is build a wind turbine out of spoons, of course, just to see what it will actually do. But I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.